Welcome, my calculus doing friends. You can tell I'm a typical Californian because the minute it gets under 80 degrees, I'm thinking I have to wear my sweatshirt. And so, but enough of that kind of talk. We have exciting business. We have chapter 2, which is the derivative. And so let's get to it. Let's see how we do here. So chapter 2 notes, two big names in calculus. If you want to check these guys out, Newton and Leibniz, you definitely can. Some homework to do from the textbook. So just some things going on. Read their stories. I tell you, they're pretty interesting. These are some proofs that are done on Khan Academy that I thought were really, really great. And we're going to come on these things, and you can go look at some of the proofs if you like. Okay, so meet the derivative, and you might be looking at this and this right here and saying, wait, that's the slope of the secant line. We did that in chapter 1. That wasn't anything too special, and so you're right. We definitely did do this in chapter 1, and so the difference quotient, right? And so the average rate of change. Now, two different notations, but these notations are talking about exactly the same thing. And I just want to show you how it would look on here. So the secant line is the slope of the line that goes through P and Q, or P and Q here, or P and Q here. So there's all different secant lines and all different slopes that go with those secant lines. So if I called this point P, if I called it A, f of A, and I called this, it doesn't matter which one of these I choose, but I'm going to choose this one, and I called this one X, then the Y coordinate would be f at X, and then the slope through this point. Oh, why did I do that? It's because that point was right there, right? I'm going to call this A, and then this point, I can't do it again because I'm already on take 4. My son said don't tell people how many takes you have, but it's probably right, huh? So this is X, and then this point right here would be X, f at X. And so the distance between my points here is X minus A, right? And so anyway, so the slope formula would be, just from basic algebra, y2 minus y1, right? So here's my y2 minus my y1 divided by x2 minus x1. There's my x2 minus x1. So that's just the slope is all that it is, with a little bit maybe different fancy notation. And this over here gets even maybe a little bit fancier notation, I don't know. But I want to show you how this would look. We'll leave that one called the same thing. And we'll call this one, instead of X, we'll call it A plus H. So now that H is the distance between them, right? And then this point here, Q, would be A plus H for the X value, and for the Y value, F of A plus H. And then when you do the slope, take away the Y's, right? Subtract the Y's, Y2 minus Y1, so I'll call this Y2. Y2, take away Y1, divided by, if I subtract these, I simply get H. We saw that in chapter 1, simply get H. And so that's different notation for exactly the slope of the same line, right? And so they're both good. We also saw in chapter 1, so none of this we didn't see in, all of this we saw in chapter 1, was that the idea that we want to get the 2 points, P and Q, very close together. And so here could be another Q value that would go with a different value of the distance between them, h, call it. And here would be a different q value. So they had these three, but getting closer and closer to p and q being the same exact value. So as that happens, if you're using the notation of calling the points a and x, the x values, then you want a and x to get very, very close together. So as x approaches a, and of the slope, and we call that the slope of the tangent line. And if you're using the notation that h is the distance between them, then you're going to let h go to 0. The distance between them is going to go to 0. And this would be the slope of the tangent line. Okay, so we had those ideas in chapter 1, and this problem could have been a problem from chapter 1. Definitely could have. And so I just wanted to show you how it would look doing the two notations. I also want to show you what they have if you go and you look at the solution guide, so that you could see. I think the solution guide might be one step ahead of us, but I think the solution guide might have made it an easy idea a little bit complicated, but that's just me. And so for us, it's saying the displacement in feet of a particle moving along a straight line, and they gave this formula. And so we don't have F, we have S, right? And so I'm going to rewrite this formula, S, and we don't have X, we have T. So S at T minus S at A divided by T minus A. And then I tell you, it does not matter if you call this A and that T, or vice versa, A and T, or T and A, it matters not. So this becomes, if I name them the way I have named them, S at 8 minus S at 4 divided by 8 take away 4, right? And then I want to find S at 8. You can see that I found it before. I told you I didn't want to print the whole thing again because, and I told you this wasn't my first take. I was honest about it even though I was told to keep it. Mum's the word, right? Plus 23. So if you don't have your calculator out and you're not putting that in, if you're trying to read what I had from before, then I really think that you're doing your notes the wrong way. You kind of want to work through these things yourself and not be a passive observer. And minus 6 times 8, and then plus 23, 7. And then we want to do the same thing for S at 4. And I'm writing it out so that you know what I'm doing, right? I'm putting in T is, now I'm putting in going to S and putting in for the input 4, right? And so I'm going to back up here. And so I already have that in my calculator. So it really doesn't take that long. And they're both coincidentally 7. And so that's a coincidence that they're both 7. So this is 7 take away 7, 8 take away 4, 0 over 4, which is 0. So the average velocity, and I think this was in feet per second, is 0 feet per second. And then they ask you to do that same thing with, instead, the interval 6 to 8, and then the interval 8 to 10. So our x values would be, our t values would be, our input values would be 8, and the other input value would be 10 into the ordered pair, right? And 8 to 12. And this is what you get when you do that. And this was a perfectly great way of doing that. Wonderful problem. And I typically just so you know, I typically think of this as ordered pair, and I say, okay, I have the ordered pair, right, because I'm trying to find the slope of the secant line, right? I have the ordered pair when the input is 4 and we know the output is 7. And then I have the ordered pair where I have the input 8 and the output was 7. And then I use the slope formula, which would look just like this, and get that. So this is my idea of what I typically do. So I don't typically use this notation, although it's fine, as I typically do that. Okay. So over here, and this is where they got pretty tricky in the book. Remember, we have S and T's, and I thought it was really pretty clever, although I might have not have thought to do it, but they did it in general. So instead of, because we're going to do this multiple times, and when they were done, so they put in here for S, instead of putting in 8, they put in T plus H, and put in T plus H, and then did all that arithmetic, and then they subtracted S at T from that, so putting in T, and then subtracting from that, and then over H, and then they got, when they got this expression for the average velocity, and they said, okay, we want our T on this one to be 4, and the difference between them is H, which is 4, and they put in T is 4 and H is 4. And then here they said we want our T to be 6, and the difference between them to be 2. So you can certainly do that, and that's in the solution guide. If you wanted to go do that, that would be great. You could also say that on this first one, I'm going to let T be 4 using this formula, and H be the difference between them, which is 4. And you could have certainly put this in. So this would be 4, and that's 4. So this is S at 8, 4 plus 4, minus S at 4. And the difference between them was 4, remember? And you notice that that gives us, right, do you guys agree? That same thing here. So all of these are the same. Now this way here of putting in the S's and the S and the T's and the H's, and then doing it at the end for all of them is very clever, and you can go and look in the solution guide for that if you want to. Okay, so they asked us to do this multiple times, and that's the reason they did it in general, is because then they could just do it quickly. But I have to tell you that my way of using the slope would be quick as well, because I would be here for this one saying you have an input value of 6, and you have for your next point an input value of 8, which I already know the output is 7, and then all I'd have to do is come here with my calculator that I already have 4 in there, and just back up and put in 6. And then I would know this ordered pair and 5. And then I could subtract them, right? 7 take away 5 is 2, 8 take away 6 is 2, 2 over 2 is 1. And very quickly I could do those, just as quickly, I think, as doing this. And I think that doing this in general is pretty up there on making it complicated. Okay, then in part B, they ask us to find the instantaneous velocity at t equals 8. Focus, my friend. My camera is starting to say that it's ready to be retire, I think. And so again, we have S's is what we have. So this could be rewritten as the limit. We have S and we have T, right? As T goes to 8, and then F at T minus F at 8, S. over t minus 8. I usually don't rewrite the notation, but I know that really confuses students when I just keep it as f and just pretend like it was f, even though they had changed the variable to be s and t, and pretend like it's at f and x. So s at t, right, is 1/2 t squared minus 6t plus 23. So this would be the limit as t goes to 8. And this would be 1/2 t squared minus 6t plus 23 minus s at 8. Well, we know that s at 8 is 7, all divided by t minus 8. If you were to plug in to use the number one limit law, right, which is substitution, it's okay to substitute. If you were to plug in right now here with 8, you would get 7 here, and 7 take away 7 is 0, and in the denominator you would get 0. So you have 0 over 0, which would mean work harder, right? So I'm going to work harder without, I guess I'll say that it's 0 over 0 so that you know that I thought about it, right? It's indeterminate form, and I'm gonna work harder. So how I'm gonna work harder is I'm gonna thinking about subtracting the 23 take away 7, which is 16. And I'm thinking about factoring out a half, because I think that would be a good thing to do. Just because I want to factor this so that this cancels with that. And so I think that it would make it easier to factor if I factored out the fraction. That's my idea anyway. And so I know that in order to, when you have something in indeterminate form, if you have a polynomial divided by a polynomial that you want to factor, so, and I know that I want to cancel the t minus 8, so I was thinking, well, if I factored out a half here in the front, so this is going to have to be 12, right? Because half times 12 is 6. And then the next one here is going to have to be 32, because half of 32 is 16. And now I have something that I think I can factor, right? So I have the half here out in front, and this is going to be t, and this is going to be t. And you know, friends, I know that it's got to be t minus 8, because I'm thinking those are going to cancel, right? So if I'm going to put the minus 8 here, and then to make 32, I already have a minus here, so I'm going to have a minus here because it's a plus 32. This has got to be 4. And then I want to verify that, hey, if I was to FOIL this out, would I get negative 12 for the center? Well, I would get negative 4t and negative 8t, which is negative 12t. So hot diggity dog. And I kind of cheated to factor it a little bit, not a lot, but you know, kind of knowing where you're going, kind of deal. And so the t minus 8s cancel out, and now I can use substitution. I can put in 8 here. So this would be half of, that's the limit, right? I found the limit. Now I am substituting in 8. So I would not write the limit symbol anymore. I just found the limit by plugging in. And so this is half of 4, which is 2, right? And this was in feet per second. Okay. Now, if we did it using this other notation over here, and we certainly could use the other notation, and so we would be putting in, you could write this if you wanted as the limit as h goes to 0 of s of t plus h minus s at t over h. And then we were told that that t was going to be 8, right? And so h going to 0, s at 8 plus h minus s at 8 over h. And so now I have to put into my function s at t, remember what it was half t squared minus 6t plus 23. I'm going to be putting in 8 plus h there. So this is a different way of doing it, but it's going to yield the same answer. So I'm going to have here half of 8 plus h squared minus 6 times 8 plus h, and of course you could have kept it t if you would have wanted, plus 23 minus 7, because remember s at 8 was 7, all over h. Now if you put in 0 for h right now, you would have, if you put in 0, then this would be the same as 7, right? Because this was s of 8, and if you put in h is 0, this will be s of 8 minus s of 8. So this will be equal to 7 minus 7 over 0 there. So right now I have indeterminate form. And so I'm going to find this. H goes to 0. I haven't found my limit yet, so I'm not done writing my limit sign. I'm going to FOIL that out. So this is half of, and if you FOIL that out, I have to get my alarm, or it's going to keep ringing. Okay, so if I FOIL this out, now you can come up here and write it twice to FOIL it, if you like. So 8 times 8 is 64, plus 8h, plus 8h, plus h squared. So this thing is 64 plus 16h plus h squared. I don't want to muck up my work here. And order doesn't matter. 64 plus 16h plus h squared, right? Minus, and then I'll do all the multiplies. You can multiply that if you want. Plus 23 minus 7 all over h. So a little bit of algebra here, a little bit of multiplying. So this is going to give us half of 64 is 32, half of 16 is 8, h, half of h squared, and minus 48 minus 6h plus 23 minus 7 all over h. So a little bit of algebra, right? So let's see, 32 on numbers, take away 48, add 23 and take away 7, right, on my numbers is 0. So 32, take away 48, plus 23 minus 7 is 0. I maybe saw that coming, maybe I didn't see that coming, but that's 0, okay? And then this is 2h. And this is half h squared over h, still 0 over 0. Then I factor out h. You could factor out more than that if you wanted, but h is enough because I'm going to cancel the h's, and now I can apply the limit using substitution, the number 1 limit law, right? And h is 0. And so this gives me 2, because 2 plus 1/2 of 0 is 2. So this is 2 feet per second. I didn't think that I would get a different answer because I used different notation, right? It did look different, but I thought I would get the same answer. You also could have done this in general, like they did in your book, right? Because they had done this in part A without putting in 8. They had left t in there, and then at the end you could have said t is 8 and etc. So anyway, okay, so we did a lovely job on that. And so that's the velocity, the instantaneous velocity at the point 8. And now they're going to ask us about drawing this stuff on there. I think I got this out of order. I wish I would have put that below it, but I'm not going to change it. So since I wish I would have put that below it, I'm just going to move it up here and then go do it. So they're asking me to draw on my graph the secant lines and then so that I can kind of look at them. So we had a secant line. This is counting by 2s. 2, 4, 6, 8. I actually got this off at Desmos, and we had one that went from 4 to 8. Remember, the interval was 4 to 8. So here I am at 4, and here I am at 8. And when I get my handy dandy drawer, and they always drew the secant lines as line segments in chapter 1. And I have to admit that I went and looked, and they drew a whole line. And I told you guys, because people were asking me, you know, does it have to be a line segment, or could it be a whole line? And I said, I don't think it really matters, because they're looking at the slope there. Remember, the slope was 0, and the height were both 7, right there. My cat is going crazy over hummingbirds right now out the window. So this is 6, and I'm going to do this one in this little teal color, and 8, right? And remember, the slope here was 1. So there's that one. And then the next one is 8 and 10. So here's 8, and here at 10. And I'm going to draw that one on here. And if I could find another color, maybe, oh, purple. I have purple. 8 and 12. So 12 is here. Oh, 12 is not going to be... I thought it was going to get off my grid, but it didn't. Okay, so they are just wanting you to look at all of those secant lines that you would have, and of course they were interested in the tangent line, and so the tangent line is the line through the point at, remember, at 8, and 8 was here about 7. And it has a slope of 2. And so the slope of 2, remember the slope of the tangent line was 2 over 1. And so that means if I go over 1, I ought to go up 2 to get another point on the curve. But unfortunately, my grid marks are by 2. So I'm going to change this by multiplying by 2 top and bottom into 4 over 2 as my slope. It still has a slope of 2. And the reason I've done that is because that when I go over 2, then I know I ought to go up. These are counting by 2 as well. 2, 4, 6, 8, 10. I need to go up 4. So that would be going over here, right? Over 2, and then up 2, and up 4. And so remember, these are counting by, each grid mark is by 2. And so I've just put 2 points on my tangent line. and I didn't draw that very well. Will I be crazy and insist on drawing it better? I don't know that but to the best of my ability, right? I had a hard time getting through that point exact perfectly. Okay, so they didn't ask you right here, but they do ask you in other questions to find the equation of the tangent line. So I just added it on to part C here so that we wouldn't have to do all of that, all of the same thing for that one extra question. And this is how we find the slope. This is how they'll find the equation of a line in beginning algebra. And what's different about calculus is they've got some fancier notation, but it's exactly the same. So this is, they call the point a, f of a, instead of calling it x1, y1. And they call the slope of the tangent line. And we're going to even see fancier notation for the slope of the tangent line. And so, Susie, you are too much. I don't know, these poor hummingbirds, they're mocking her, though. There's like 8 of them out the window, and they're definitely mocking her. And so to me, I would just be saying, well, I have the point 8, 7, remember? And so this is my, my x1, y1, and my formula. I would just use my beginning algebra formula. And so y minus 7, and the slope, remember the slope of this line that we're looking at was 2, right? 2 x minus 8. So that when the dust clears here, we get 2x minus 16. We add 7 over there. And is that 9? Negative 16 plus 7? Yeah, negative 9, right? Y equals 2x minus 9. And I guess and so finding the equation of the tangent line, I was going to then verify that, hey, what other points would be on here? Negative 9 was going to be off my grid for me to check. Why don't I put in 10 and see where I'm at 10? So if we put in 10, we get 20 take away 9, which is 11. And hey, I can buy that this is 12, right? And I could buy that that's halfway in between at 11. So perfect. So anyway, so that's the equation of the tangent line. They didn't ask us to find the equation of the tangent line on this particular problem, but I added it on. And I guess that we really don't have x's and y's like I have. We really have t's and s's, right? This is s. And so this, if I wanted to have it in their notation, the tangent line would be s, is 2t minus 9. So great. Okay. So you're going to learn about this mathematician, Joseph Fourier series. I wasn't able to say that, getting that going. Some people say Fourier, I think. And so he said that mathematics compares the most diverse phenomenon and discovers the secrets that join them, that unite them together, right? And so that's really true. I got my cat's driving me crazy, so I'm kind of distracted. I'm sorry. And so unable to concentrate almost. I got to get back on calculus. Hummingbirds are not that interesting. Calculus is interesting, right? And so all of these things are rates of change, and that's what we've been finding is rates of change. So velocity, density, current, power, temperature gradient, all of these things are rates of change. In economics, the marginal cost and the marginal profit are rates of change. in sociology, the rate of a spread of a rumor, or the rate that fads or fashions change, are all rates of change. And all of those are just, and this is just kind of what he was saying here, you know, that, hey, there's a secret that puts all of these things together, and that is the rate of change is the derivative. And that's what we're going to be looking at in chapter 2. And so if you're thinking, you know, that, hey, they went back and they started talking about, you know, these things that they talked about in chapter 1, the slope of the secant line and the slope of the tangent line. Well, the derivative is just the slope of the tangent line. So anyway, and so here I just kind of tell you that the derivative is the slope of the tangent line. This is some notation for the derivative at the point A. Some people read this f prime at A, and remember this was the slope of the tangent line, and other notation for the slope of the tangent line. And there's actually lots of notation that go with the derivative. So M tangent line, they were already using that notation for the derivative. They didn't say it was the derivative yet, the slope of the tangent line, but they were already using that. And as you go through math, you'll see a lot of this notation for the derivative. And this derivative, these notations were come up with by different people. So df dx is a way of denoting the derivative. dy dx. If you're thinking about dy dx, it kind of makes sense. Remember, it was a slope, and that's the change in y's over the change in x's. And that's also notation for the derivative. These are notations for the second derivative, so you notice the 2 for the second derivative. So that's taking the derivative of the derivative, and we're going to see that that has application. And so the prime notation, so writing f prime of x, this is the second derivative, f double prime, the third derivative, f triple prime. If you're wondering, to make the fourth derivative, yes, they do use it, and people put a 4 there instead of using 4 hash marks because it gets to be a lot. Some modern notation, just writing y prime or y double prime for the second derivative, and some Newton's notation with dots over the top for the first derivative and the second derivative. So there's lots of notation for the derivative, and so this is a lot. We're going to be using this a lot, this notation and this notation a lot. We're going to also use this notation here. You're going to see this notation in differential equations, and so anyway. So just to sum up, the slope of the tangent line to a curve at a point A is the derivative. Some people say the slope of the curve at a point A, and that's the derivative. The instantaneous rate of change at a point A is the derivative at the point A. And of course, we had this was the derivative, and this was the derivative, right? And so just to make sure that, hey, we're talking about the same thing, because they'll ask you to find the slope of the curve at a point A, and you'll say, what the heck is that? And it's the derivative. Okay, so here, this is the last problem we're going to do. I'm really glad because my cat is going crazy, and I'm pretty hungry, and so I just want to show you that using either one of these, that you should, that using either one of these, my answer might look different, but that we're finding the same thing. So anyway, so here, f of x minus f of a divided by x minus a. So let's put that in here. So f of x would just be the normal, right? So this would be 4 over the square root of 1 minus x. I forgot my limit. I'll back up and hang it on there. I'll put f of a like this, f prime of a, x goes to a, and minus, and then when I have here 4 over the square root of 1 minus a, all divided by here, my limit maybe should have been bigger, x minus a. If you, this is what I'm finding the limit of, right? Definitely the denominator is 0. And if you put in a here, you're going to notice that you're going to get, those are going to be equal to one another. So I definitely have 0 over 0. And so it's a matter of how would I simplify this up? And so the first thing I notice is I have a complex fraction. So I would want to multiply by the common denominator to clear that complex fraction. I would want to multiply by the square root of 1 minus x multiplied by the square root of 1 minus a, top and bottom. I'm going to do that. And so that's going to look like this, the limit as x goes to a, and then I'm going to multiply here by 1 minus x times the square root of 1 minus a, and I'm going to do that to the numerator here, 4 over 1 minus x square root minus 4 over 1 minus a, and to the denominator, so when I multiply this, a monomial, times this binomial, here the x minus the square root of x minus 1 minus x is going to drop out, right? And I'm going to end up with the limit as x goes to a of 4 times the square root of 1 minus a, right? These are going to cancel out, and that's what I'm going to be left with, minus, and then when I take this whole monomial and I multiply it times the second term in the binomial, the x minus a's are going to, the square root of 1 minus a, I can't say that, is going to drop out, and I'm going to be left with 4 times the square root of 1 minus x, all over that crazy denominator, which I'm not going to multiply together because from the beginning I know that I was hoping to reduce with the numerator because this was 0 over 0, right? When I put this in, I was hoping to reduce this with that crazy numerator. So the numerator was looking so complicated, but the denominator's not too complicated. So now the denominator's looking more complicated, but I'm just going to try to ignore this stuff. So 1 minus x and x minus a. So I put parentheses around each of those, but this is all multiply, and I am not going to multiply in the denominator. Now, if I plugged in, I have 0 over 0, because if you put in that x is a, this is 0, and 0 times this other stuff is 0. If you put in x is a, then these are exactly the same. And so I'm still at 0 over 0, and I haven't canceled anything out, so I didn't expect to be anything different. So I really probably wouldn't have checked that out, but I have made it look better. And now at least it's not icky fraction. And so what I have to do, I could factor out a 4 and then multiply by the conjugate, or I could leave the 4 in and have to reduce it out later. But because they have a common factor of 4, I think I will factor out the 4 and then multiply by the conjugate. And so I'm going to factor out the 4. And then I'm going to multiply the numerator and the denominator. Oh. So this is not calculus right now. This is algebra, right? And I'm going to be multiplying by the conjugate here. And that's why I say that it's algebra that's hard, not calculus. And same in the denominator. What you do to the numerator, you got to do to the denominator, and vice versa. So I'm multiplying by the conjugate. And remember, I want to cancel the x minus a, so I'm not really gonna physically multiply on the bottom, but I am going to multiply on the top. And what I'm hoping for in the top is an x minus a. So here I am. I have not found my limit yet, so that's why I am still writing my limit. And so I'm going to get, when I multiply by the conjugate, I'm going to do FOIL, but the outer and the inner are going to make 0. So I'm really going to just focus on the first. So there's the first, which is 1 minus a, minus the last, which is 1 minus x. And notice I put parentheses around it, because the 1 minus x particularly, because I have to distribute that negative. So this is a minus of a binomial, right? And so the square root was acting as the grouping symbol. Now I'm putting in a parenthesis to act as the grouping symbol, and the same denominator that we had. Here's the part I want to cancel. And so I kind of have a whole big multiply situation in the denominator, right? This times this times this times that, binomial. So when the dust clears in the numerator, again, I still am at 0 over 0 until I cancel that x minus a. I will be. And here you can notice it's going to work out, right? Because this is going to be 1 take away 1 is 0. It's going to be minus a plus x. So I have 4, and this is going to be minus a plus x. And over this whole denominator, the square roots, the parenthesis that has the x minus a in it, and the square roots added together, right? I got lazy and didn't write that in there. And you notice that this is backwards of this, so I could factor out, I could just write it in the other order, sorry. They're not backwards of one another, it's just written backwards, but they're exactly the same, right? So I could write this as x minus a, and then it would cancel directly with this. So now I am ready to find my limit by doing substitution, because now when I substitute, I'm having to fit that in there, when I substitute, it won't be 0 over 0. So I'm going to replace x with a here. So I'm going to have 4 over the square root of 1 minus a times, you're replacing the x's with a, and you're leaving the a's alone. So the square root here of 1 minus a plus the square root of 1 minus a. Wow, right? So this is 1 minus a. And this is the square root of 1 minus a plus the square root of 1 minus a is 2 square roots of 1 minus a. And the 2 will cancel with the 4. So if you had chosen to multiply by the conjugate and left the 4 in there, then you would have had more to cancel, but it would have still worked out the same. So the 2 and the 4 are going to reduce out and give me 2 in the numerator. And in the denominator, this and this are, I want to think of this as 1 minus a to the first, and 1 minus a, remember the square root is raised to the half. And so these have the same base. So I could add the exponents together. 1 plus half is 1 1/2, which is 3/2. So this is 1 minus a to the 3/2. And wow, right? F prime a. And I'm like, wow, this video is long, 49 minutes long. and our class is 50 minutes, but I'm going to go ahead and finish this one, this other one, just to show you that, hey, you should get the same thing, right? And so let's give a try to it, and then you can decide which one you think is the best here. So we're going to have, when we plug in a plus h, so f prime a, the limit as h goes to 0, and we're going to have 4 over 1, and you have to be careful, minus, I'm going to write this up here, I have 4 over the square root of 1 minus, and you fill in the blank, right? And what we have to put in the blank is a plus h. So do you see what I was saying about having to be careful? It's really going to be minus a minus h, because parentheses are implied when you substitute. And so this is minus a minus h in square root minus 4 over, and then when I put in a just in there, 1 minus a over h. You can clearly see that if h is 0, that this is 0 over 0. And so some of the same pieces are going to be happening along. I have to multiply by the common denominator to clear that complex fraction, which in this case is 1 minus a minus h times 1 minus a. So when I do that to the top and to the bottom, so this is my derivative, I'm going to have this binomial just like I had before. So I'm going to do that to the numerator, and I'm also going to multiply by the same thing in the denominator, because what you do to the numerator, you got to do to the denominator, times h, right? I'm going to write it like that. Okay, and I know that I want the h's to cancel out. So this is a monomial, and I'm going to be distributing it to this binomial. And when I do, these cancel out. So if you're thinking it's similar to the work that we had over there, you're right, it is. And I'm going to be left with 4 times the square root of 1 minus a minus, and then the square root of 1 minus a is going to cancel, and I'm going to get 4 times the square root of 1 minus a minus h. You don't have to do it both ways. The reason I'm doing it both ways is people tell me, oh, I used the wrong formula. And that's the reason my answer is different. But I'm trying to show you that shouldn't matter. Okay, so now I'm going to multiply by the conjugate, just like we had to do over there, and I'm going to factor out a 4 and multiply by the conjugate, just like I did over there. So 4 times I didn't write that right. So I have this. And then I'm going to multiply by the conjugate, which I'm going to run out of room. So I feel like I need to get a piece of paper over here. It's like I should have used this room over here, because now I'm over here and I'm starting to have major stress on whether or not I'll be able to fit this on here. This is some pretty gnarly algebra, but it's plus, right, in between. what you do to the top, you got to do to the bottom. So I'm multiplying by the conjugate, which is this same thing, but a plus in between. Okay. So this is my limit as h goes to 0. So remember the same thing we had over here, the FOIL, right? The outer and the inner are going to cancel, and I'm going to be left with the first and the last. So I'm going to have my 4. I'm going to try to write that small. And then I'm going to have my first, which is 1 minus a, minus, and then I'm going to have my last, which is 1 minus a minus h. And you're going to have to go until you can cancel the h. Before I was trying to cancel a binomial, but now I'm trying to cancel, that's an a, and that's an h. Now I'm trying to cancel h. It's a lot to write. And so what happens up there in the numerator is I have 1 take away 1, which is 0, negative a plus a, which is 0, and minus, and then h, right? And so minus times negative h is a plus h. So I finally get here the limit as h goes to 0 of 4h, the rest of it went to 0, over this square root, h, right, times, this is times, and times, all this is times, and so, and here this square root, 1 minus a, plus, and then the square root, 1 minus a minus h. So I had here 1 minus a minus h, and 1 minus a, and the h's finally drop out, right? Because I have a monomial times h times a binomial, but the h's factor out. So h's drop out, and now I can finally apply the limit, which is to substitute in that h is 0. So remember, this is my derivative, right? And I'm going to apply the limit now. H is 0. So that gives me in the numerator 4, and in the denominator it gives me 1 minus a, the square root of, times the square root of 1 minus a, and then here when you put in 0, you're going to get the square root of 1 minus a plus the square root of 1 minus a. And that should be familiar, right? That's what I had here. And so it would simplify here to here to here. So dot, 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 right? If I hadn't done this over here, I wouldn't be wanting to jump to this. So I should get the same answer, even though I used a different formula. And so it might look different from a while. That's what I was saying. It might look different from a while, but it should be the same. Okay, so we did, oh my gosh, an exhausting job there. Gonna quit it. So we'll see you in the next video.